Hi students, this video is regarding your next part. So where you are going to work with the insertion of a node, okay, in the doubly linked list. So last class we have seen that how to create or how to declare a structure of the node which you are going to create, and then also we have seen that how to create a nodes like n number of nodes, something like this. So now we'll be working on with inserting a node. Now we have actually an empty thing. Actually, already we have two nodes now here. Now we are going to insert a node in the front or middle or end. Okay. So as the front node is usually like very familiar with that, we'll work with the adding the node in the middle of the list. That is somewhat tedious task. So in that regard we'll be working with that particular thing now. So we be having already existing two nodes actually which we have created a node n and we have created a node x. So and also they have been virtually connected by mentioning your or updating your next pointer and the previous pointer. So which we will be connecting in two ways, in the forward direction as well as the backward directions. Now we have to have a node in the middle. Okay, now I have to move, actually like I have to create a node here and I have to just create a like I have to break this link, okay, between the first node and second node. Now I have to make a new node to be in the middle of these two nodes. Okay, that's a logic here which we are going to implement it. So actually like I'm searching for symbols where I can just take it, and so that I can able to just put an arrow mark so that you'll be able to understand that link further. Yeah, I think this will be okay, fine. Now we'll be having a concept where you're going to insert a node in the middle. Okay, so now we'll just take a node here. I have to create now one more node. So where which I'll just same thing where I'll just create one more node here. Then I'll just have star. Y. The star is nothing but a dereferencing operator. So once I have given this y, then what I have to do? Then I have to just copy this. Okay, again you can write it so that you will understand the logic further and more. Okay, so instead of copying it, please write and practice that n number of times so that you'll be like very familiar with writing the syntax. So I'm just creating the node as I'm just converting that void pointer which returns by the m block and C lock, okay, and that is to be a structure pointer, and the memory size should be in the structure size. So that's what I have given. So once I have given this, what happens now? The node has been created, new node has been created in a structured way. In a structured way is nothing but we'll be having three components. So these things were being created now. So it has been like created, and so with some garbage values. Okay, some garbage value will be there once you just given here. So some garbage values here. Okay, now I need to like replace the values of these things. So I'll just write y, then data equal to some values. Say I just give 6. So once it is given 6, so this garbage value will be replaced by 6. Next I have to so this is where we have actually, I'll just cut this, I'll paste it here. Okay, so this is my new node. The node address is say some 2000, and this node name is y. Okay, so now we have created a new node, and now with the garbage values we have this, and this garbage value I can just, because directly I could not I should not replace. Okay, directly like whatever I can directly either replace with your value, or else I can just initialize that with a null. Okay, this with the null, then that can be again you can replace with the existing data. I'll just have that previous to null, and then again I'll be having the next to null. So this has been replacing my garbage values. So always you do this practice. So convert that to null, and then you can replace that with your value, because that sometimes some compiler it just create an error. So if you're directly replacing the garbage values, so always have the practice to convert or to replace the garbage values from the like m block like only for M block, not for C lock. Okay, so M block only like allocates a memory with the garbage values. Okay, for that I just replace that garbage value with a null. Then you can just replace with the value which you want to address to. Okay, so here now we have the new node. Now the structure has been given and it is also given in a new space, and it has been placed. Actually everything is done. Now the thing is like only one particular thing has been left, which is nothing but to create a virtual link between this and this, because we have already a link here. So already we had a link, so I'll just represent this link. So I don't find any shapes. Maybe like this line will be helpful. No. So I don't get that line actually. That's the thing. Okay, I'll just let me search for that. If I have, I'll just use that line, so that we'll be understanding that in a good way actually. Okay, I didn't find, so maybe like I'll have to just take some time for that. Okay, in that regard, okay, from the next video I'll just try to take that link and show you how to create a link. Okay, as of now I'll just create a link in colors. Okay, so here is like I'll just use the blue color to create a link. Okay, so this is this is thing like where you have one from here to here and here to here. We have two-way link actually. This represent two-way link. Now what is our main objective is like I have to break this link and I have to connect this link over here. Okay, I have to connect this link to this actually. Okay, this has to be 1000 now. Okay, like this I have to create a link between these two, and this actually this has to be given connected here. Okay, okay, I'll just draw in a paint so that you'll understand better. Okay, so here, so now we have a list like this. Okay, we have already we had two lists. So we had two node in the list. Okay, and this is my n node, and the address of this is 500. Okay, and this is 1000, and I have one more new node, so which is in the memory space of 2000. Okay, so thing is like what is there now, like now the thing is here we have 1000, so which indicates that this is the next pointer, next node address actually. So it creates a virtual link from here to here, and then this is my previous node. I have 500 here. So what happens is like once I have 500, it indicates the previous node for this node is 500, so it just directly pointing a virtual link is established in a backward direction representing this. So this is how it is there. Now I need to insert this node in middle of this. So our objective is like to break this link. I need to break this link. Okay, now I have to break this. What I have to do is I have to like break this link, and I have to regenerate the virtual link. Okay, with the new node. Okay, I'll just take a break on this to come back. Okay, 1 minute. Yeah, we'll just start with the session now. So here is like we have now I have just to break the link between these two nodes. So now what we have to do is we have to connect this node in the middle, right? So in this case, this is a 500. So my next node is 1000. So I have to change this to 2000 because my new node address is 2000. So I have to make this 2000 to be the next node, because I'm going to insert, I'm going to bring this in the middle. I'm going to bring this in the middle. Okay, in this case, the 2000 should be the next node of this, because we have already break the link. So in this case, what I have to convert this 1000 to 2000. I have to replace this. Once this is done, then I generate a virtual link from this to this, because it is a thing is representing that 2000 is my next node. So now virtual link has been established here. Then I have to say here in the new node, the previous node is 500. So then the previous value from null I have to change to 500, so that it will be connecting the backward direction to this. Okay, so now we have been established the new node connection from the first node and this node, and now I have to establish a new virtual link from the third node and this node. I have to make this a second node now. So in this case my next node should be the node with the address 1000. So the next node address should be 1000. So if I give this, then defaultly it just generate a virtual link to point to the next node. Then here, before it was 500, it was linking here, but we should link this one, right? So here this previous node of this is then 2000. So 2000 should be the previous node. Okay, once you given this, then there will be an backward link is generated between this node and this node. Now a node has been inserted in the middle. Okay, so this is what we are going to see as in the representation part. So now we got the like this is how you have a node now. So this is your already existing node, and this is my second node, and this is my first node, and this is my new node. So need a virtual link to be established, that to be in the middle part. So in this case what we have to do is I need actually like the new case where I'm going to work with the position, because I can just, it is not like in the middle, in the sense I can have like think in the scenario that we have the nodes like 10 number of nodes. So in the middle, in the sense we have to like mention the position, that is called middle. So middle is nothing but it is going to insert the node based upon the position. Okay, so here in this case what I'm going to do is we are going to have a function. I can say inside the function, this is my inside the function. So I'll be having one more thing, like what have now, like I'm just going to declare that a loop, okay, because I need to traverse until my position reach. Okay, so I'll be having a thing, so where which I'll have int I, and then I'll just having the position also as a variable, and then the element which I want to insert it. So these are the three variables I required to insert an element in the position based. So in the middle also same and position is also same. So I is a loop variable and POS is a position and ELE is an element which you want to insert in the middle of the list. Okay, so these three variables have been declared. So now what I have to do is, then I want to take up the input from the user asking for the element which you want to insert. Okay, enter the element which you want to insert. Okay, uh, which you want to insert. Okay, so this is the sentence which will print on the screen. By seeing this, a user will able to insert the element, like what element they want to insert it, and also we want the position also. At what position you want to insert? At what position you want to insert it? Okay, so this is position you want to insert. Okay, so we are trying to receive two input. Okay, so one is the element which they want to be in the list, and other is where it want to be in the list. Okay, once we receive it, then we just scan that input. Okay, and then we just load that in a thing, because we are receiving two input, then we have to mention it as two format specifier with a integer, because we have declared this as integer only. Okay, so then once I receive this, first input is like what element they want to insert, right? So that once we receive the element, I have to load that into a variable called element, and then second input will be what position they want to insert. Then that has to be like received, and it has to be loaded in the variable called POS, and you have to make sure that the order is maintained, because you have asked first the user to enter the element only, enter element which one you want to insert. So in that case the user will give the first one is the element only. Okay, and then second one is your where you want to insert as a position. So once you receive this, and then please load that into the variable element and the position. Okay, now what we have to do is, after this, then you can just create a new node. Okay, after this we will be creating this. Okay, we'll just take this and I will place it here. Okay, so once this is done, then a new node is created, because we need now only, like once it is done, what I'm going to do is, whatever the element I have received, that element I'm going to like inslice that with the data. Okay, so this will be my element which the user enters, whatever the user enters, that will go find a place here and sit it. Okay, for example, if I am the user, I'm just giving the value 8. Once 8 is received, that will be loaded in the variable space called element, and then after receiving it, then that from there it will be taking and it will be given to the node data. So the 8 goes here now. Okay, before, like in this position, in this particular execution, it is coming to the element variable space. Okay, after this, after executing this line, like y data, y is nothing but your node, the data is nothing but the component. Okay, in this, if you are giving an like initializing the LE value, ELE means nothing but in this LE is nothing but a variable name where which it is holds the data information 8. So once you give this, then my y data takes up that element now. Okay, now the 8 is going to the node data. Okay, now what happens, now there is like there is no previous node link and there is no next node link. That is where we are involving now. So how this can be done? So what we can do is, we can have always we will be having a head pointer. So head pointer is which we have to create it. Okay, we will just create a head pointer. So we'll be having a struct node head pointer. Okay, and then we will be having 2 pointers more, because what we can do is, I'll be tracking this position. To track the position, I'll be taking 2 pointers. One is the old pointer, the other one is the new pointer. Okay, I'll just have to give star, and then again I have to give star. So I have created 3 pointer variables to track your node. Okay, so everything is done. So creation of head point is done. So what I'm going to do is, once my head is created, I always will be like so here is like we'll be having a 3 pointers now, which means that we have a head pointer and we have old pointer and we have new pointer. What we're going to do is, we are going to like we need actually like this also and this also, the address of both the things. So in that regard, we use 2 pointers, and the head pointer is always pointing to the head first node, because we don't know the address of the first node, right? So to get that, okay, always your execution starts from head node only, head pointer only, because head pointer is a pointer which stores the address of the first node. So we do not know that which is first one. So to get that first node, we always track the head pointer. So head pointer is equal to n. Okay, so because n is the first node, so once you give this, okay, we have a head pointer. So this is my head pointer now. This will looks like I have a pointer which is pointing to the first node. My first node address what, 500. So I'll just take it. So from here only I used to track, I used to start. I can say that I'm going to start from first node now. I have to start with head. First to go to head, get the 500, then go to the address 500, then fetch the element. This is how we have to work. So once I've given this head is equal to 500, now what I'm going to do is, I'm going to start all the pointers in the first node. In that regard, I just initialize all the pointers to the first node. Okay, I am just creating old pointer. This is also pointing to the first node, and new pointer. This is also pointing to the first node. So because so that my all pointers it can be started. Okay, now my all pointer, what happens? I'll just starting with all pointer. Okay, so I have a node now. Okay, so this is my first node now. All pointers is starting with the first node. So this is my first node now. In this case, all my pointers. Okay, so this is my head pointer, and this is my old pointer. Okay, and this is my new pointer. So now everything is pointing to the first node. This is the thing. This is OP. OP means old pointer, and new pointer means new NP. So this everything it is pointing to the head, I mean first node, because we have initialized the address of 500 to all the pointers. Now this is done. What happens is, now I need this pointer, like one pointer should be stay here, the other pointers has to go in the front. Okay, the other pointer has to follow up. Okay, in this regard, so I need to like iterate through the loop, where which I am working with the informations. Okay, once this element is like given, so I'm just now iterating the loop for getting the position. Now the position they have given us 2. Okay, so element is 8, the input element is 8 and the position they have given us 2. Okay, so in the second position they want to insert it. So this is the first position and this is the, now it is second position. Now I want this second position to be replaced by new node. So this second position I have to traverse the list until it second position is reaching. Okay, once I reach the second position, then I have to insert this node to be in the second position. So to iterate the loop, I use a loop variable for I is equal to 1 because I am starting with the first position only. So I is equal to 1, then I have to stop when my I reaches the position, okay, the position whatever the user enters. So I am just doing this loop and just opening that. Okay, inside that what I am going to do is I am going to have this, because here my pointer is now moving. Okay, now the pointer has to move to track it actually. Okay, so this is my new node actually, so I'll just erase, this is my new node actually, this is my old node, these two are the old nodes. So now what I have to do is I have to move this new pointer here and this old pointer has to follow the new node, new pointer. Okay, so new pointer will be moving here, okay, and then old pointer stays here. When new pointer is moving to here, then the old pointer should be here. So this is the concept. Okay, so my new pointer is moving one step forward. Now the old pointer should be following the new pointer. So in the loop what I am going to do is, okay, in the loop what I am going to do is I am going to have old pointer equal to new pointer. Whenever you just start with the loop iteration, each position, okay, whenever your iteration, first iteration, the first pointer is moving and again the second iteration, my old pointer should follow up the new pointer. Okay, so we'll see like how it is working in the iteration part. Okay, so now the old is equal to pointer is equal to it is your new pointer. Next is like where we will be having the, this new pointer will be the, we have to change the location of new pointer, right. So new pointer is equal to, so new pointer is equal to new pointer next. We'll see how it is working. Okay, don't worry. Okay, next we'll just close the loop. Okay, this is what happening. We will see like how it is working. So now we just take up the, okay, we'll just say take up this. Okay, we'll just have this as a new. I'll just create a node, consider this as a node. I'll just fill this. Okay, I have a node. Okay, this is my node and this is my node. Okay, and this is where you have head, then I have old pointer, and this is where I have new pointer. Okay, this is my first node. So this is my thing, and the next of this is we have 1000. Okay, we have 1000 and the previous one is 500, like this. Okay, so this is where we have, this is my first node with the address 500 and this is my the next node where which I have the address as 1000 and this is my new node. Okay, with the address 2000 and this is my pointer to store the previous, this is my data and this is the pointer to store the next address. And again we have previous pointer, data, next, we have previous pointer, data, next. So this is the structure of the each and every node is completed. Then I have given the next node to be 1000. So once this is given, then a new link is established here now, and once this is given 500 and then this has been established here. Okay, so here is also null because there is no previous node, this is also null because there is no next node. Okay, so this is what before as a existing nodes. Okay, so now this is the node n and this is node x and this new node is y. So already we got the element 8, okay. Now everything is null now, so nowhere it is connected, okay. So now what we did is we have 3 pointers now. We have the head pointer, and we have old pointer and new pointer. I'll just draw the head pointer here. It is always pointing to the first node. I'll just have it as h. Then this is my old pointer, this is op, and this is my new pointer, this is new np, okay. So now this is a starting position now, okay. This now the iteration starts. What does iteration says? For I is equal to 1, for I is equal to 1, I less than position, okay. First I is equal to 1, so 1 is less than position is 2, okay. 1 less than 2 are true, okay. It's coming inside. So old pointer is equal to new pointer. So now old pointer, where is old pointer, new pointer, both are in same position only. Old pointer is equal to new pointer, yes. Next what happens now? What I'm telling you, new pointer is equal to new pointer next. What is new pointer next? This is my new pointer. New pointer next, what is that? 1000. Now the new pointer in the first iteration, it is moving to the address 1000. Okay, now the new pointer is in 1000, the old pointer is in 500 only. Old pointer is there only. I have moved the new pointer. To move to the next thing, I have to have this next to be the initialized point. You can see here, new pointer is equal to new pointer next. New pointer stays here. Now new pointer is equal to next is 1000. Now this looks like exactly new pointer PTR is equal to 1000. This is how the thing is happening. But new pointer is equal to 1000, then which means that I have this pointer is moving to the address 1000. Okay. In the first iteration, the new pointer is moved to first iteration, the new pointers move to 1000, and old pointers, because we have after this there is no execution for old point, because already old pointer value is 500 only, it is there only, okay. So there is no change in the old pointer, okay. In the first iteration, these two are the values of old pointer and new pointer. Now the loop again continues. So I is equal to 2, because I plus plus I becomes 2, 2 less than 2, no, it is false. So it is coming outside the loop, okay. Now the new position of new pointer is 1000, and old position of the position of old pointer is the 500, okay. This is where you think the iteration completed. Now it is coming outside the loop. Now my or our objective is like, I have to link, I have to break this link, then I have to create a virtual link, okay. So the new node has to come in between these two nodes, okay. That is our objective. In this case, what we are doing is, we are just taking up, we have to make this, okay, we have to make this new node should be given as old pointer order next, okay. So I have to take, no, this is your previous node, right? Previous node is what? 500. 500 means what? N, okay. So in this case, what I have to do is, I have to take up this new value, okay. So old dot next, okay. I can just mention this old, this is nothing but old pointer order next, okay. I have to change this to 2000, because only then the next pointer address of this is 2000 now, okay. So in this case, what I have to do is, after coming outside, I have to write old pointer PTR old pointer next should be the address of the new node, okay. If I give this, what happens? Old pointer, okay, this is old pointer, this or next one, it is giving the address of y. You should give only y, not ampersand symbol and all, okay, y, which means it takes the address of y and it has been replaced that, okay. Now the old pointer next will be changed to 2000, okay. Now the 1000 has been replaced with the 2000. Once you give this, what happens now? A virtual link is established like this, okay. Now the next node of this has become 2000. So now the virtual link has been from here, it has been removed and here started here. Now it is pointing to the new node, okay. Now I have to replace this previous node, because I want to change this previous node to what? This 500, okay. In this case, what I can do is, new node or previous is equal to this node, okay, n. So in this case, what is my new node? My new node is y. So y previous is equal to n, previous is equal to n, that's it. So n in the sense, what is my n? N address is 500. So this will be 500. Once I give this 500, so the previous node link. Okay, so now the backward direction is also established. Done. Okay, now we have to connect this side. Okay, so what I have to do is I have to take this new pointer previous. I have to change new pointer previous to y. Okay, I have to connect this actually. Okay, I have to make sure that I am connecting this. Okay, these two. This case, what I can do is I can just take new pointer, new ptr previous is equal to, I have to give y. So here this previous will be changed to 2000. New pointer previous is changing to 2000. In this case, we are just connecting in a backward direction here. And I have to bring this next node to here. In this case, I have to give y next is equal to new pointer or x, anything is fine. Okay. So in this case, what I am going to do is y, okay, y next pointer, okay, y next is equal to, I can give x, okay, that's it. So now in this case, what happens, old pointer is equal to next, old pointer next is equal to y, in the sense old pointer order next, this one, it is connected to y, y is nothing but 2000, so 2000 y value is replaced here. Okay, and then y previous is equal to n, y previous now this is a y, so previous is this one, so y previous now this one, in this case I have to give n, n is nothing but your new, the node address 500, so I give 500 will be replaced here. Okay, so this is the snippet where you just create a virtual link in the doubly linked list, that's it. Okay, so here this is a loop, okay, which you want to follow for iterating throughout the position. So each iteration, each position, okay, the new pointer and old pointer value will get updated. One step minus will be there, one step back the old pointer will just traverse, new pointer will step one step forward of the old pointer, that's it. Always the old pointer follows the new pointer. For example, if my position is 3 now, in this case second iteration, my new pointer will be like moving towards the forward directions. Okay, maybe like in this case I will take some other address. Okay, next address will be 2000. So in this case now I will be taking the forward. Now the old pointer will be the new pointer's old position. Okay, old pointer OP is equal to, so what is the new pointer before value 1000, that will be the thing. Okay, now the old pointer is following the new pointer. So for each iteration this order you have to maintain. Okay, you have to first initialize the old pointer, then only you have to move the new pointer. Okay, because if you are updating the new pointer, the old value of the new pointer will not persist. In that case, take the old value and use it and initialize it, and then you change the new value for the new pointer. So the order you have to maintain it. Okay, so this is how you insert an element or a node. Okay, I should not tell element. This is how you insert a node in the middle of the doubly linked list. Okay, so here the three things you want to remember in inserting it. First thing is like you want to create 3 pointers, okay, where which we have to load the address of the first node, that is one pointer purpose. The other 2 pointers is like to traverse the list until your position reaches, so that I can just use one pointer, it is to give the next pointer address and the previous pointer address of connecting these two back side and front side, and this again other pointer we need to get the address of the next upcoming, the forward node, okay, the future node. Okay, in this case we will use 2 pointers, and also we traverse the pointers one step forward and the other pointer will be going back of the new pointer. These things you want to remember, and the logic where which we traverse the list, this is where you traverse the list and to get the position, and this is where you just connect the new node with the middle position, middle of the node, middle of the list, okay, in terms of position. Okay, and this is how you insert a node at the middle or insert the node at the based on the position in the doubly linked list. Okay, that's it regarding the insertion part of the based on the position. Okay, and regarding the beginning and end, we'll see in the next video. Okay, thank you, happy learning.